Fusion Mobile, quality e-learning experience on the go.
Equilibrium, as we know, is simply a state of no observable change, where there is a kind of a balance, and of course, a reversible reaction is a reaction which can occur in both directions, so far as the condition permits it. Most of the time, reversible reactions occur in sublimation of some ionic substances, say ammonium salts. It sublimes, and when the condition is right, it comes back to its form again. It could sublime and turn into two different substances and return back to its original form. What are the characteristics of the system with chemical equilibrium? The characteristics of system with chemical equilibrium. Firstly, they always occur in closed systems. Any system that is going to have a chemical equilibrium must be closed. The chemical reactions must be reversible, and the system must be dynamic in nature. This means that at every point in time, the amount of reactants and the amount of products being formed is equal at every point in time. That's what is stated in the fourth one. The concentration of all substances in the system must remain constant as long as the reaction condition remains constant. And introduction of a catalyst also should not alter the equilibrium. All these principles, all the part of it that I know may give you a little challenge is the concentration of a thing. For a system to attain chemical equilibrium, it does not necessarily have to have the equilibrium from the beginning of the reaction, but from the point of the equilibrium to the point of the end of the equilibrium, the total concentration, the concentration of each of both the reactants and the products is constant throughout the entire chemical equilibrium duration. Now, how do we calculate chemical equilibrium? Of course, they have the formulas up on the slide, and the Lecheter's principle. Lecheter's principle states that if an external constraint, such as change in pressure, temperature, concentration, is imposed on the chemical system, the equilibrium will shift to neutralize or to annul this change. For example, let's say I won't take into consideration the sublimation of ammonium salt. Let's say the ammonium salt is in a particular, of course, it must be in a closed. It must be a closed system, which means it is in a closed place, it is sealed up, and the ammonium salt is being heated from beneath. Now, as it is being heated, some of it is subliming, and when it gets to a certain level, it condenses and returns back as the ammonium salt. When it gets to a certain level where the rate of sublimation in both directions is equal, then it is at equilibrium point. Now, if the temperature is increased, there is a chance that the level of the rate at which the condensation will occur will differ, would vary, and will reduce compared to the rate at which it would turn into gasify. So at this point, what will happen is the point of the equilibrium will shift further towards the sublimation point where it gasifies rather than it solidifying. So that is what the principle is trying to explain.
Fusion Mobile, quality e-learning experience on the go.